Okay, in this problem, we have a system doing a power cycle, is receiving at 1,000 kilojoules of energy through heat transfer at a temperature of 500 Kelvin, and then discharging at 300. Those are all the heat transfers. So I want to figure out what sigma would be for these two different efficiencies, and then figure out, hey, what does that mean? Is it reversible, impossible? What do I have here? So our equation for sigma is, again, negative for a cycle del Q over T, which is essentially basically Q hot. It's the sum of the Q hot. Well, let me do it this way. Q hot over T hot. So that's Q in minus Q out, which will be cold over T cold. And again, what I know here is that I receive it at 1,000 and 500, discharge it at that. Okay. Now, the other thing that I know is that my efficiency for this guy is going to be 1 minus QC over QH. Okay, so I'm going to use this, knowing that my efficiencies are like this. I'm going to use this to help me find, because the only thing I don't know up here is essentially QC. I'm going to use this guy to help me find QC. Okay, so for the 60%, okay, well, let me do it this way. I will solve this for QC, set that equal to QH times 1 minus the efficiency, right? And again, QH is 1,000. Efficiency is either 60 or 20%, as shown here. So I can rewrite my sigma equation to equal, again, QH, that's 1,000, over TH, which is 500, okay, minus QC, which we now know is QH times 1 minus the efficiency divided by TC. Now I know everything in this equation, and I can actually solve for sigma. So again, let me go ahead and plug things in here. So again, QH is 1,000. TH is 500. This is QH, excuse me. QH then is 1,000 times 1 minus 0.6, 60%, divided by temperature of 300. Gives me a sigma equal to negative 0.667, and that would be kilojoules, kilojoules per Kelvin, right? That is impossible, right? Because my sigma has to be greater than 0. That's what the Clausius inequality tells us, is that this number has to be bigger than 0. Doing the exact same thing for the 20%, I get negative 1,000 divided by 500 minus 1,000 times 1 minus. Now I put in 0.2 for the efficiency, divided by 300. Now this time, I actually get a sigma of 0.667 kilojoules per kilogram, not kilogram, excuse me, per Kelvin. Okay, and this is an actual irreversible system, right? Because again, the Clausius inequality states that this has to be a positive number. Okay, since it is a positive number and not 0. If it was 0, it would be reversible. Okay, here it's irreversible because it's positive. Here it's impossible because that sigma is negative.